Hey everybody. At this point, we've now looked at the importance of precision in forecasting, as precision in the propositions or statements that we're considering when we're forecasting, and also in the predictions that we make, by giving precise probabilities or intervals of probabilities. And we've also looked at how to formally assess the quality of forecasting judgments using the Breyer score. This measure, the Breyer score, will privilege probabilistic forecasts that are resolute and well calibrated. Now the question we turn to is, given a precise set of statements, how can we be good forecasters? What practices can we employ that will help us to make accurate predictions? In this video, and in the videos for Friday, we'll look at some informal rules of thumb that so-called super forecasters employ while forecasting. Ultimately, some of the logic of these informal rules will be made precise in the scientific inductive logic that we'll end up crafting next week, namely probability theory. Okay, in this video I want to talk about the difference between foxes and hedgehogs. So, when Philip Tetlock did his research on expert political judgment, he looked over a long span of time at how good political experts were at making forecasts about upcoming political events. While most political experts in his study were not terribly good at making accurate political forecasts, he found that a small subset of folks were relatively good at making forecasts, often beating random chance, so their predictions really were worth something. Tetlock investigated what distinguished experts who were really good at forecasting from those who weren't so good. And when he found that it wasn't really ideology, right, whether they were conservatives or liberals, or level of education, whether they had a PhD or not, that explained this difference, it was rather how they thought or how they approached forecasting problems. Tetlock identified two rough groups of people: the foxes and the hedgehogs, right? And this imagery is taken from a famous essay by the philosopher Isaiah Berlin. The quote that Isaiah Berlin based his essay off of is a quote from an ancient Greek poet who said that a fox knows many things, but a hedgehog one important thing. And in Berlin's essay, he basically goes through the history of philosophy and he classifies some philosophers as hedgehogs, as people who think about just one big idea, and some philosophers who are foxes, who take a different standpoint or don't have just one big idea that sort of is the overarching theme of their whole work. So the basic idea is that hedgehogs have a big overarching idea through which they view everything else, right? So for example, right, maybe some, if we're thinking in terms of economics, some supply-side economists might have a tendency to be hedgehogs if they view the economy entirely in terms of supply-side economics and the benefits of tax cuts to economic productivity predicted by the Laffer curve, right? Or a Marxist might, on the other hand, right, have a tendency to be a hedgehog if they view the entire economy through the lens of just the labor theory of value, right? In any case, right, a hedgehog is someone who fixes on one big idea and interprets everything else in light of it, right? Foxes, by contrast, are more eclectic, right, drawing on a variety of different tools and ideas more narrowly fitted to particular problems, right? So foxes are less likely to focus solely on one big idea or one overarching theory, but they try to look at a problem very contextually and from different angles or different points of view, right? Tetlock noted in his work that foxes thought much more in terms of probabilities and possibilities than hedgehogs who thought more in terms of certainties, and also that foxes more easily changed their minds and admitted errors than hedgehogs, although that's difficult for anybody to do because both foxes and hedgehogs have some difficulties with confirmation bias and over confidence and such. So there's no doubt, right, some benefit to the hedgehog standpoint. Maybe if you're crafting some sort of grand metaphysical system like Plato or something, maybe it pays to be a hedgehog there. But Tetlock found that when it comes to empirical forecasting of the sort we're doing, for example, in our class forecasting project, foxes significantly outperform hedgehogs, right, in terms of their accuracy as measured by the Breyer score. We can gain some intuition for why foxes might be doing better than hedgehogs, according to Tetlock, by thinking about the wisdom of the crowds, right? Now, the wisdom of the crowds is an old idea that dates back to the work of British scientist Francis Galton, who was an early pioneer in formal statistics. In 1906, he went to a county fair, and he asked folks to guess the weight of an ox that was at that fair. Right? So hundreds of people at this fair submitted guesses, And Galton found that the average guess was 1,197 pounds. And that was remarkably close to the actual weight of the ox, which was 1,198 pounds. Even though most individuals weren't that close to the correct answer, right, individually, their collective estimate, the average of all their estimates taken together, was incredibly accurate. Right? This phenomenon is known as the wisdom of the crowds, and it's been observed across various domains. Right? One place we see it is in opinion polling. Right? While opinion polls taken individually certainly have some accuracy to them, aggregates of polls, or averaging across different polls, sometimes called a poll of polls, tends to result in far more accurate forecasts about who's going to win an election. This is what led to, for example, Nate Silver's famous predictive successes and a lot of the work at his group 538. So what explains this phenomena of the wisdom of the crowds? Well, each individual has some knowledge or some information that they bring to the problem at hand, and also some error, right? In aggregate, the knowledge or information that various individuals possess will tend to converge on the answer, right? It all tends to point to the truth, right? Insofar as it's real knowledge or information. While the errors they bring to the table will be relatively uncorrelated with each other, and so they'll tend to cancel each other out when we average, right? Leading to the average being relatively accurate. Now, what does this teach us about forecasting and foxes and hedgehogs? Right? Well, one lesson perhaps is the benefits of teamwork, right? Tetlock has found in his work with the Good Judgment Project that aggregating the forecasts of individual forecasts tends to result in relatively accurate forecasts. So this is part of why I put you all into teams for the forecasting project. Right? Secondly, though, we can view foxes as employing the wisdom of the crowds at an individual level, right? That is, as having a sort of metaphorical crowd in their minds, right? By viewing an issue from different vantage points and trying to think of different possibilities, foxes are aggregating the insights of different perspectives and hopefully washing out some of their errors. Right? So one example of fox-like thinking that Tetlock discusses in his book is involves the guess the average game. Right? So this is a famous game in game theory, and how it works is that players are asked to guess a number between 0 and 100. And whoever guesses closest to 2/3 of the average guess wins some prize. Okay? So how might you play this game? Right? Well, you might think, okay, people are guessing numbers between 0 and 100. People are just randomly putting numbers down. The average would be around 50. And so maybe I'll guess 2/3 of that, right? And so that would arrive at the conclusion that I should guess 33. Right? But if you think other people will also think that way, then the average will really end up as 33. And so 2/3 of that would be 22, so your guess should be 22. And if you repeat this reasoning over and over, each time thinking that others will do this similar reasoning, then you arrive at what economists call the unique Nash equilibrium solution for the game, which is for everybody to guess 0. Right? So when this game is played in experiments, there are a fair number of people who will guess 0. Right? Those are the people looking at this from the perspective of sort of rational game theory. But 0 almost never wins, right? The usual winner is typically someone who guessed around 20, right? So what went wrong for the people who guessed 0? Well, arguably they were hedgehogs, right? They only looked at the game from the vantage point of economic rationality, right? But there's also the vantage point of psychology, right? Which says a lot of people will not employ the chain of reasoning that leads to the Nash equilibrium solution. That is, a lot of people will give a naive answer like 33, right? A fox can synthesize these two perspectives and guess something in between, like maybe around 20, which is often close to what the average is. And of course, in this game, right, we could factor in even more perspectives, and Fox would then try to figure out how likely it was that everybody who's playing the game would take each of these different perspectives and so on, right? So, right, in this guess the average game, Fox-like thinking can lead to better results than just taking one standpoint, like a naive guess like 33, or a guess that only looks at things from the standpoint of economic rationality like 0. Right? It's also worth noting that Fox-like thinking, or taking into account different viewpoints and different tools, rather than relying on just one big idea, can, in this domain of empirical forecasting, help us correct for some of the biases that we saw last week. Humans are often prone towards, like overconfidence or confirmation bias. Right? By taking into account different possibilities and considering different perspectives, we can highlight the possibility of our own error, and thus help correct for our tendency to be overconfident on various matters. All right, so that's the key idea from this video. Takeaway: fox-like thinking can outperform hedgehog-like thinking in forecasting tournaments, as it brings some of the wisdom of the crowds down to an individual level and helps correct for biases like overconfidence and confirmation bias. All right, so that's the key idea from this video. I encourage you to read more about this in the readings for this week from Tetlock's book, which are on the Canvas site. Remember to complete the participation poll for this video, and I'll see you next time. Thanks, guys.